Hi there. We're going to take a look at testing cloud apps. Why we want to test our cloud apps? Well, like any testing, we want to create tests which exercise certain user interface elements and then makes assertions or expectations about what should happen in our app as a result of those actions. And we put these tests in order to be more confident about changes that we make to our app in the future. A suite of regression tests can allow us to make changes knowing that we haven't broken anything along the way. Cloud apps are built in Angular, and so we can use many of the same tools and methodologies that are used to test Angular apps to test our cloud app. So to get started, let's take a look at the documentation. So I'm here in the developer network, and I can go ahead and click on the Cloud Apps link, and then click on Documentation, and then click on Testing Cloud Apps. And that will give me a run-through for how to set up my testing environment. We're going to come back to this in a few minutes. Now, in order to demonstrate testing, I thought it'd be a good idea to take the scaffolding, which is the default out-of-the-box application that you get when you create a new cloud app, and add some tests around that scaffolding. And that will allow us to learn a little bit about how to use some of the Angular testing capabilities to test our cloud app. So Angular testing, as we said, is based on using standard Angular tools, such as Jasmine. So Jasmine is the library that's used for the actual testing, and Karma, which is the test runner, which allows us to test our apps, to run all the tests and see what the results are. In addition, because we are using material controls in our app, so we can use the material harnesses, test harnesses, and that will allow us to more easily execute and operate actions and query the screen for controls and then click them or test if they're there. So Angular testing, Jasmine, Karma, test harnesses, we'll come back to all of that. Let's just take a look at the standard app that comes with a newly installed, newly created cloud app. That's the scaffolding. So here I've done ECA init to create a new application, and then I've run ECA start to start it up. It's running here in my browser, and this is my app. Let's just make sure that we're running here. I can go in and click on the Cloud App Center icon, pin that there, open up my app running in my local development environment, and I have this welcome message. And then if I go ahead and look for some kind of search query inside of Alma, we see that my app provides a list of entities that are displayed. I can click on an entity, and it displays the selected entity here in this card. In this text area, it displays the data which is returned, so it ran the API to retrieve data about the selected entity. In this case, it's an item. And then it returned the data and put it in this box. I can go down and find something I want to update, such as year of issue. I can update that to 2018, for example. Click on the update button, and then the scaffolding app goes and does a put request to update the item. It refreshes the screen here in Alma and then shows me a success message. Okay, so those are all of the kind of basic functionality that the scaffolding app does. So we can come back out of here. So if we're thinking about that, we might want to think about what types of tests I would want to run for my scaffolding app. So what type of test would I be interested in? So first, I can confirm that when there's a list of entities in Alma, it shows that list of entities in the cloud app. That's the first thing I can test. I can also test that when I select an entity with the radio button, it displays that selected entity in that card. Then I can also confirm that when I select an entity, it goes and calls a REST API, a GET request, to retrieve that selected entity. And then I can test that it populates that text area with the results of the API call. And then I can confirm, I can validate, assert that when I click the update button, the put API is called when the update button is clicked. And then finally, I can test that if there are no entities in Alma, then I will see the welcome message in the Cloud App. If you recall, when we first went to the Cloud App, there were no entities in Alma because we were on the dashboard, and the Cloud App, there was a welcome message. So these are kind of 6 tests. There are probably more that you could think of that you want to test, but this will give us a good start to understand how to do testing in Cloud Apps. So what we can do is we can go ahead and stop our app from running, because when we run tests, we use the test runner instead of the actual app which is running. So the first thing that we're going to do is we're going to go back to our documentation, to the Testing Cloud Apps page, and I'm just going to copy this basic test script, which is here. I'm going to copy this test script, and we're going to create a new file in our component folder called main.component.spec.ts. And anything which is spec.ts, that's what the testing framework is going to pick up. So spec.ts indicates a test. And we notice we have some red squiggly lines, meaning some things aren't working correctly. So first of all, this is testing something called a testing component, and instead we're using our main. So let's just do a quick search and replace. Everywhere it says testing component, let's say main component. Let's go ahead and replace all. And that's it. We have no more squiggly lines. Let's just take a look quickly at what it's doing. So the first thing it's doing is it's describing our main component. It's creating some members, component and fixture. And then it runs a couple of before each tests. So before each is kind of like setup, which is run before each test is executed. And it's configuring a testing module. So in our Angular app, we have this app module, and that imports all of the dependencies that the app has. When we're running the test, we're not running with the app module, so we have to create our own imports and import some things that these apps use, like the form module, the reactive form module, material module, etc. And then we're running a very simple test. Oh, and then in another before each, we create the component. And then we run this detect changes. Detect changes execute change detection so that the template updates. And our first test is very simple. It should create. So we just want to confirm that that the component has been created. And down here in our terminal, we're going to run Eca Test. So what Eca Test does is it's just a wrapper on the standard Angular testing procedure, and it's going to kick off our Karma test runner, and it's going to actually execute our test. So it's going to scan all of the files in our project and look for anything which is spec.ts, like ours here, and it's going to then run, kick off the test environment and run any of these test files. Look for before each, run them, and it's going to do that in a browser. So it's going to kick off an instance of Chrome. You can also see the results here in the terminal, but of course looking at it in Chrome is probably going to be easier for us. And it's going to kick off our Chrome, going to pull in all the dependencies that it needs, and then it's going to run our test suite. And what's nice about this test runner is that much like when we have a debug local version of our app running using Eca Start, anytime we make a change in our app, the app refreshes in the screen so we can see our change. The same thing here in the test runner. Anytime a change is made to one of our tests or to our app, the test will be rerun, and we'll be able to see the results. So therefore we can do an iterative process with our tests as well. So we've done all of the bundle generation, and we see that it has run one test that the main component should create, and that test has passed. So we have the basics up and running, and we're looking good. We recall that the first thing we wanted to do to test was to test that it should show a list of entities. That was the first test we wanted to do, meaning that if I have a screen in Alma where I have a bunch of entities, I want to see those entities inside my Cloud app and a list of them. So there's actually a lot involved here, and this first test is going to be one of the hardest to get up and running because we have to do a number of things to get this to work. If we think about it, what's happening inside of Alma when a list of entities is loaded? There is an event service, a Cloud App event service. And that Cloud App event service has a subscription that the Cloud App can subscribe to, and therefore can be notified whenever the entities change in the Alma screen. That's how it works. And if we just pop over here to our main component, we see that in fact it creates an observable. And it uses the observable entity which is on the event service, and it does some piping, but it's using the event service in order to get a hold of that entity's observable. And the way that the event service is provided to our component is through the Angular dependency injection system. So in our constructor, we tell Angular we want a Cloud App event service, and the dependency injection engine knows where to get that service. But when we're running our tests, we don't have Alma. And so we have to be able to give our tests a mock version of that event service so that our tests can run even if it's outside of the world of Alma. So we have a few things we want to do here. First of all, we are going to import a whole bunch of things from a file called Cloud App Testing. And this is just a file that, that I've created with a bunch of constants and some functions, so I can reuse it later in any of my components. So I'm just going to copy this from this GitHub gist, and I'm going to go back here and I'm going to create a file called cloudapptesting.ts, and I'm going to paste that in here. And again, it's got a few things. It's got some constants, and you see here this is a page info. So this is what actually that event service is sending to Alma every time the entities update. And I've got some hard-coded entities in here. We have an empty page info that I can use later. We have some other things too, like a REST response, and we'll get into that in a few minutes. And we also have a mock event service. So this mock event service has a similar interface to the Cloud App event service. It's got an on-page load handler, and it's got that entity's observable. And that's going to allow us to manipulate the entities that the Cloud App thinks it has. Let's go ahead and save that, and let's go ahead and import a bunch of these things into our test spec. So we'll go back up here, and we'll import all of these empty page info. None of them are being used, as you see. That's why they're all grayed out. All right, the next thing we want to do is we want to add another before each. So back in our component spec, we had a whole bunch of before eaches, and we want to add another one, which before each, it's going to call this page load subject and send it next with that page info. And that is replicating through our mock event service what would happen if Alma navigated to a page with entities on it. So this before each, it means that on each time we run a test, the test is going to think that Alma has sent it a bunch of entities. Which entities? The entities that are here listed here. So it's a bunch of items, 3 items. So that's good. So now we have, let's go ahead and just save that and make sure that everything looks okay. We haven't added any tests, so there's no new tests to add. So there's still just one test, and it still passes. So we're good there. The next thing we want to do is what we're actually we actually want to test to see that the component is displaying radio buttons for all of our entities. And in order to do that, we're going to make use of that test harness that I mentioned before. These are special classes that the material library provides to us, and it allows us to more easily query material components which are on our template. Now, there are other ways within the world of Angular testing and Jasmine to do this. I happen to like the harnesses because it makes the programs much easier to see. We're doing less direct DOM querying. So I'm going to go ahead and copy these imports and paste them here into our test spec. And then we're going to create some of these components. So we're going to define a loader, and the harness loader is the way that we are able to access some of these harness classes that we'll need. And then we're going to, in our, before each, we're going to add this as well. Now let's do it after the changes, so in case there are any, that doesn't think it matters actually. So we're going to now load our test bed harness for our component, and that's going to go through and identify any of the material components which are on the template. Okay, one more thing we have to do. So now we have all of that plumbing in there for our test harness, which is great. And we know that we made a mock event service. But we have to tell our component, our testing module, where to get that event service from, because it doesn't know. Remember, it only knows the modules that we've imported here. So we have to actually go and say and add this providers element to our testing module and say, you know what, I'd like you for if the component requests the Cloud App event service, we'll just import that, then I want you to use my mock event service. Remember, my mock event service is that event service we have here in this page. So we're telling the dependency injection engine that when my component requests the Cloud App event service, I want it to use my mock event service. And now the test bed, the test environment, knows where to get my mock service from. Woof, that's a lot. And then the last thing we can do is finally we can add a new test after we've done all of that. Finally new it, and it is a test in the world of Jasmine. So we're saying it should show a list of entities, and it's going to use that loader that we created to get all harnesses of type radio button. So it's going to load into this constant called buttons all of the material radio buttons that are on our screen. And then we want to assert that the number of buttons that should exist on our screen is the same as the number of entities we have. And that is a way of saying that I want to make sure that my component is displaying a list of entities according to what it received from the mock event service. So let's go ahead and save that. We're going to let it rebuild. It's going to take a minute because it has to pull in from the material all of those libraries now to build out. And it's going to refresh. Now it should have two tests. One that it should create, and the second one that it should show a list of entities. So remember, in our before each, we sent the component a list of entities, and then in our tests, we confirm that there are radio buttons now which reflect that list of entities. So that's great. So we're moving right along. That was a lot to get through that test, but we saw a bunch of things. We saw how to create a mock event service, how to tell the test module where to get the event service from. So now that the DI engine knows where to take the service from. That's our mock event service. And we use those material test harnesses to make some assertions about material controls that appear on our screen. Now we're moving along. Our next test is we want to display that the entity which is selected. So I'm going to have to click on select one of these buttons. And when I do that, then my component should display the selected entity inside of that card. So I just want to add this constant entity index as 1, just so that anytime I reference which entity I'm clicking on, I'm referencing the same one. So we'll just go ahead and add that here as a constant, and now we can continue. So I'm going to grab this new test. We'll add it here to our bottom. And it says should display entity selected. So the first thing I'm going to do is our component has a selected entity member attribute. If I go back in here to our component, there's a selected entity. Its entity at the beginning is undefined. So in my spec, I'm going to validate that at first undefined. And then I'm going to grab all those material radio buttons, just like I did in the previous test. I'm going to check the button that I've selected here, which is number 1, which is actually the second one because it's a zero-based index. And then after that's done, I'm going to make another assertion that my selected entity should now be truthy, meaning it should have a value in it because I have checked that entity there. So let's go ahead and save that test. And let's go ahead and run them and wait for the response to come back. And so far it's run 1 test. But I have that dreaded red X. Why do I have a red X? It tells me there's an error. When it's running the test, should display entity selected. That's the new test I just added. The async function did not complete within 500 milliseconds, meaning there was something that was called that never got completed. So if we're trying to understand what was called that never got completed, we have to remember that in this scaffolding component, when I select a radio button, a few things happen. It populates that selected entity member and then displays it in the card. But it also performs a REST request to Alma to request back data. And then that data is used to display in the text area. So apparently what happened here is that we ran a REST request, a REST API, but of course there is no REST service in our test environment to run. So it just went into the Netherlands and never came back. So that's going to help us work with another methodology for services. Previously we saw this mock service, and here we're going to use what's called a spy. So a spy is a Jasmine concept which allows us to do just that, to spy on any calls that are made to a service and do something instead of whatever that service was going to do. So in our Cloud App testing file, we have here a function called the REST spy. And what that function does is it asks the dependency injector for a reference to the REST service in this case. And then it says, I want you to spy on, okay, the REST service. And I want you to spy on the method called call. And instead of doing whatever that service would have done, I want you to call a fake. And the fake is, in our case, we're just simply returning an observable of our REST response. And our REST response is what an item response from Alma would look like. A link, a holding data, item data, etc. And then this function is going to return that spy. So we're spying on any requests to the REST service. And instead of actually making a call to the REST service, we're going to respond with our own hard-coded response here. So I'm going to define a spy on our component spec up here with our class members. And then I'm going to add another before each method. And in this one, I'm going to say before each, set the spy to this REST spy. And because I'm doing this on before each, now any test which would trigger a REST API call will go to my mock as well, which is going to return hard-coded that response. So let's go ahead and save that. And let's see again what happens now. I haven't added any new tests. I'm just trying to make the second test work. And in fact, what I see is that it shows a list of entities and it displays the entities selected. So now our test has passed. As a matter of fact, we can see that the results of that test, so indeed this second radio button was checked. The selected entity is displayed here. And also we see already as a hint for our next test case that the results of the API call, in this case our mocked API call, are displayed here in the text area. But that we're going to get to right now. So moving along, we have these 3 tests. We have 2 that we've added, and And the new methodology that we learned in this past test was how to use spies to intercept calls to our service and return back a hard-coded result instead. Our next test is we're now going to confirm that indeed the REST API was called when our entity was selected. Okay? And so now we're going to add a new test. We don't have to add any new spies or mocks or anything. We want to do the same thing we did before. We want to get a hold of our radio buttons. We want to check that radio button. And now we know that when you check that radio button, Alma, or our component rather, is supposed to go and do a REST API call with the link that's provided in that entity. And so the way that we're going to do that is we're going to use our spy that we configured up here in the before each. And I want to expect that this service that the spy is spying on, which is our REST service, we expect it to have been called with the link from the selected entity, from our page info entities and the index. So we're going to, expecting the spy to have been called with allows us to, again, peek into what our component called on that service. We're looking at the REST service and the call method, and it knows that, or it validates that the REST service call method has been called with the link that was selected. And indeed, that shows green too. Excellent. The next thing we want to do is we want to populate the text area with that data. So we're going to validate that this text area, that it got back the correct response from Alma, from our mock REST service in this case. And it's going to validate that the text area contains what we expect it to contain. So in this case, again, we're going to do the same thing. We're going to get our radio buttons, we're going to check the second one. We're going to find our text area, and the way that we're doing that is, we'll just handle that import there, is that we're going to look, here we're using, we're querying the element for a text area element. And once we get a handle on our text area, we're going to expect the value of the text area to contain part of our response, like the barcode, for example. So let's go ahead and save that, wait for our test to run again, and we see that the tests run very quickly. Now we've got all tests running, they're showing green. Notice they run in a random order each time, so we never know what's going to wind up on the screen because they run in a random order, and they finish very quickly. So now we have validated that it gets the REST response back and puts it into the text area. And then the next test I want to do is I want to validate that it calls actually this should be a put API when the update button is clicked. So in order for me now to click the update button, I need to import one more of these harnesses. Remember, these are the material harnesses that allow me to easily get a handle on my material components. So I'm going to grab that, and then I'm going to grab this test, and let's see what this test is doing. A new test. And in this new test, I'm going to do the same thing. I'm still going to get all the buttons and then click the second one. And now I am going to look for a button that has the text update. Right? If we recall, we have a button which has a text update. And so that's just a way of finding the right button. And I'm going to click on that button. So now I am clicking on that button using my test harness as if I were a user clicking on the update button. We'll handle this import as well. And then I'm going to use this expect spy to have been called with, just like I did before, except instead of a string with the link, it's going to be called with an object this time because it's going to specify the method should be put. So I use this object containing, and I want to confirm that the REST API, the REST service, my mock one in this case, was called with an object that contains the method for put and the URL for my link. And that verifies, I could do more things here, like I could verify that the body contains the body that's there, but this is enough for our test. So it's going to run all my tests, and it's going to add that last one as well. And that last one is going to, here it is, should call a post, should be put API when the update button is clicked. All right, we're now down to our last test, and the last test should show the welcome message when there are no entities. So we'll grab that and we'll place that here in our test spec as well. And what we're going to do here is we're going to send another page entities into my observable. And this page entities is the empty page info constant with an empty entities. And that simulates going back to the home page, the dashboard of Alma, let's say, going to a page where there are no entities to display. And then I want to grab a hold of the h1 tag, because we know that in the welcome message in our template there's an h1 tag. And I'm going to assert that the h1 tag exists and that its text content contains welcome. And that will verify that if there are no entities, which is simulated by this, then I show the welcome message. I will save that. I will go back over here to our Karma runner, wait for it to refresh, and now in less than a half a second, all 6 plus the show create 7 of our tests have been run, and they all show green. And so that gives us the confidence that if we make changes to this page in the future, we can run these tests and make sure that nothing has broken by accident. So we've seen a lot here in this video. We have gone from the basic, which is taking the scaffolding out of the box after creating an ECA init, a brand new app. We added a basic spec. We copied it from the documentation, from the Cloud App Testing documentation, and then we gradually added more and more tests to our test spec that facilitated all of our test methods. And we used mock services. We used a spy to keep an eye on calls to our REST API and then return some hard-coded data. We used the test harnesses for material. And all of that in order to be able to put together our test suite for the scaffolding. And I hope that you can take some of these methodologies that we showed here for the scaffolding test cases and use them in your app as well. Thanks.